All right, I'll get started here. So this is the webinar on building effective agents with the OpenAI Agents SDK. So the Agents SDK is like, I think it was released a couple of weeks ago. It's not that long ago. And so what I'll do in this webinar in the next couple of minutes, I'm going to go through some examples of how to use the library. There are a lot of things that I still need to learn about the library, but I think it's hopefully with this webinar provide you a good starting point, and then also allow me to share some of my own experience building with agents and how it translates to something like this. There's a lot of like agentic frameworks that you might have heard of, like AutoGen, CrewAI, and so forth. And I think there are a lot of overlap and similarities, but I think there's also a lot of really cool features that were introduced that I really like personally in the Agents SDK. And so hopefully I will go through that. Towards the end, we'll have a Q&A. I think you should be muted throughout the presentation. That's totally fine. But we're going to have a section towards the end for allowing questions. Also, feel free to ask questions in the chat. We have someone helping us today to collect the questions. So towards the end, also we'll gather some of the questions from the chat, and then have a section going through some more details on any interesting questions that you may ask. So I'll get started with the presentation. So what is an agent? I think that's really important. For me, at least, there are a number of definitions, even our definitions over time. We have like a few courses like here on where we get to define agents very early. And over time, I've had to revise my definition for what an agent is. And I think that's totally understandable. I think as the field evolves and develops, and we have new functionalities, newer models, newer capabilities, I think having a static definition, it doesn't make too much sense for me, and it will always evolve, especially with the capabilities that we're seeing recently. And so for us, where we stand, I personally like the definition from Anthropic. This is a new post that they released. So they have like an engineering blog, and if you haven't checked that out, please do check it out. I have a link for it here. It has, I think, good guidance on what are agents, right? What are the workflows that actually work, and how to build these agents in an effective way using things like prompt engineering, and specific like design patterns that actually work for these agentic workflows. And the reason why I like it's not only because of the definition that they use, but also because I think the workflows that they mention in the blog posts are workflows that actually work for us on our use cases as well. So just to give you a quick background, I do a lot of stuff on education, but I also do a lot of consulting work for AI companies, specifically like startups. So we get to build these things into like production settings, like working with LLMs specifically. So I get to share that here in presentations like this, but I also like to look and learn from others as well, other companies, and how they're defining things, what is working out for them and so forth. And that's something I recommend anyone that's getting into the space. I always look out for what others are doing and so forth. So at a high level, I think the way I would define agents, and again, I have adopted this definition and it has evolved a bit, but I think agents can be defined as autonomous intelligent systems that can accomplish simple to complex ended tasks through the use of various tools. So what do we mean by simple, and what do we mean by complex ended task? So also, I think it's really important that I think something that's a simple workflow could also be considered an agent. So here in this definition, the simple agentic system. So both of these are agentic systems, but this would include a simple workflow that potentially could involve like an LLM, maybe a tool call, and then maybe some predefined control flow, right? So you do this in code, and it's deterministic, it's predictable in the sense that you're controlling how the agent behaves, right? What's the next step that it takes? So this is what I mean by the simple agentic system, which includes these workflows. We're going to talk more about workflows and show you some examples, concrete examples on how to develop them using the Agents SDK in a bit. And then I think for terminology, again, purposes, the more advanced, I would say, complex ended task would include agents that are made up of LLMs. That it could be one LLM, two LLMs that can autonomously is the keyword here, perform more complex tasks through capabilities like reasoning. So we have all these reasoning LLMs. We have the reflection, the ability to reflect. If it makes a mistake, it can backtrack and so forth. And then also the ability to use multiple tools. So again, this This is useful if you have the OpenAI task, right? It's not predefined. You don't define a control flow. You basically allow the model through some orchestration. So I'm going to show an example of that to go through multiple loops until it completes a task. So these are good for OpenAI tasks. Okay, so that's kind of the definitions. Those two definitions, again, could change over time. We could have new types of workflows, and you can totally expect that. But where it stands, I think this is the definition I like. Okay, so how to build effective agents? So I think also borrowing from the building effective agents blog post from Anthropic, again, highly encourage everyone to go and read that. It's a longer post, but I think it has a lot of nice clarifications on things that might be confusing for the community. So I think it's important to also like just consider working as starting really simple. Start with a basic flow using the LLM API calls. Just code things yourself. And I think one thing I like about the OpenAI Agents SDK is that it encourages that in the sense that it's easy to use, easy to get started, as you will see, and it gives you that flexibility to be able to make it complex, customize, use the built-in features, or just basically just use Python code to stitch things together. So I like that. I like that flexibility. A lot of other frameworks are too abstract for me. I won't mention the framework names because I want to focus on this particular one from OpenAI. But I think that's the one thing that I really like so far from my usage with the Agents SDK from OpenAI. All right. And then what I suggest, right, as you create these simple workflows for any task that you're working on, you want to measure, you want to evaluate at every step of the process, right? This is not something we're going to discuss in this webinar. I think it's autoscope. It's a very, I think, very deep topic, but I think that's something that that is important as you develop agents. So start very simple, then work your way up to more complex agents. And I'm going to show you like a workflow myself that I use for testing out things, testing out ideas. In particular, how you would use that using the Agents SDK. That's the idea. All right, as we go, please, if there's any confusion, anything that's not clear, please use the chat. We'll be gathering all the questions towards the end and then answering questions. So for those of you that just came in, that's how I'm kind of doing the webinar. Okay, so what is the OpenAI Agents SDK? So what is this about? So it was formerly known as Swarm, and I think OpenAI just had like a side project, developed this. I think they had some kind of thing that they were shipping and they posted. I think it was a research project. They shipped this on GitHub, and I think it gained popularity, but it wasn't really serious of a project. This is for educational or research purposes mostly. But I think they saw the opportunity, right? Because there's a lot of like frameworks out there. They have different approaches. Some use graphs, some use different ways on how to stitch together agents. Everyone has their own way, but there's obviously a lot of overlap with these frameworks. And so I think it made sense for OpenAI being like one of the top LLM providers to have something like this, where you can orchestrate agents with something that's more custom made for their endpoints, right? Their APIs. And I think that makes sense for them at least. For us as developers, it's always good to have many options to experiment with. I always say, don't overcommit too much to a framework, especially as I mentioned earlier, that things evolve really fast, like definitions evolve, like capabilities are evolving still. So that's something to always keep in mind when you want to overcommit to a framework. Always make sure that you have that in mind. So again, allows you to orchestrate agentic applications with very minimal abstractions. So for my usage so far, there are 4 key capabilities, which we'll get into. We'll have some demos for each one of these. So like agents, yes, we're going to have a recording. I saw that in the chat. Yes, if you need to leave early, please feel free to do so. We'll have the recording. I will send the recording link after, maybe 2 hours after the webinar ends. So we have agents, right? Agent is the main thing. Agent is powered by a language model, and it has like instructions. It has tools, access to tools, and it also has like hands-off. Handoffs is a specific feature that allows you to orchestrate multiple agents. I'll talk about that in a bit with a concrete example so you know what it is. But again, it's delegating tasks to other agents. This allows you to build a very complex agentic workflows using very minimal code, essentially. And that's why I think this feature was introduced. And it's a very key feature of the library, so it's one to talk about in a bit. We'll talk more about it in a bit. So guardrails, I think it's an interesting one, because like so far, I think when we build LLM applications, we sort of we stitch things together, right? We have a prompt, maybe the prompt outputs something, and then we use that output into another one, and then we have this sort of like flow, right? And I've seen developers that do this, like where they don't really check or validate inputs, or they don't validate outputs, right? And that's a really bad idea. So you can validate information easily now with this library. You can validate, whether the LLM is outputting the right information. And that's very useful for a lot of applications, because once you built in this validation parts, you basically improve the reliability of the system. As we know, these systems are non-deterministic. Sometimes they would output information that's unexpected. And so you want to account for those. And I think this is the reason why they introduced this guardrails feature. So more about this in the following examples that we'll introduce in a bit. Tracing, I think, is something that I really like about this library compared to, other like frameworks out there. And the reason is because it's built in. And it's actually something that's supported in the OpenAI platform. So if you are a developer using OpenAI models already, and you have an API key, and you have access to the platform, the playground, and so forth, in those settings, you will find a specific, part where they have traces and logs. And logs and traces are everything. Like, we work with logs with our applications. We have to look at the logs. It is part of the process of, evaluating and measuring whether your application is doing the thing that you want it to do. And because agents make things so much more complex, there is a need for tracing. And there's a lot of really cool tools out there. I think popular ones would be like Comet Opic recently, receiving a lot of traction. There's also Langsmith, which a lot of you might have been using already. But OpenAI also introduced their one as well. I think it's very early days from what I've seen, but I think it's a good starting point. And again, it's built in, it's supported by default on the inside the Agents SDK library, which I really like, because then that reduces, how much effort I actually have to put. If I need to change any setting, or if I need to use another tracing provider, I can always do that with the library. That's also supported. Also, on that note, with agents, right, standard LLMs from OpenAI are supported. You can also use the reasoning LLMs, but you can also use other LLM providers. I saw someone ask me, I think on Twitter, whether this is this is like a vendor lock-in. No, because the library actually supports other providers in terms of tracing and in terms of agents, and that's really important. Because sometimes you want to mix when you're building these agents, especially multi-agents, you want to mix different LLMs, right? You want to use different LLMs for different components, and so it's really important to have that capability. And I think they figured that out very early, and they have the ability to do that. All right, so let's go with the first example. I think this is the exciting part. This was just a quick intro. The links are there, right? Check it out. There's also some links. I'll mention this link before I forget. Some references here. The one that I've been using is the documentation. So go to the documentation here on the OpenAI Agents SDK. There's also more information about agents right here. So this is sort of an introduction guidance on people that are maybe new to agents. And then this is the Anthropic blog post that I'm referring to if you want any information regarding terminology and what really works with agents, right? What are the type of workflows and components that actually work? All right, so let me get back here. So this is the first hello world, and I have a code folder here. I think everyone should have access to this. If you don't, please shoot me an email and we'll get this fixed. But everyone should have access to the scripts that I'm going to demonstrate in a bit. So this one is the hello world. And basically, it's just telling you how to implement with the Agents SDK, implement a basic agent. And this one is just a hello world. So you can see here, I think these are just standard libraries. I'm not going to go through all the code, but these are standard things that you would do. And then you basically set your OpenAI key. You have different ways how you can set this. This is the way I set mine, because I'm using a .m file. So I'm just using the standard best practice here. And this is the OpenAI API key. Again, you will need OpenAI. If you're using their standard LLMs by default, you will need an API key, right, for this. So you need to have a paid account with them. And then this is just an agent is instance, right? So this one, basically you can give it any name. The name is important here because that's what's used in the logs and traces. And then you want to give it something descriptive here. And then instructions is basically, think of it like a system message, like high-level instruction for the agent itself. So what it's supposed to do, what it's supposed to perform, anything that you want the agent to be aware of, that's where you will put it. And then this one runner that runs sync, there's different ways to run this class, but basically this one it triggers the workflow itself. So this is the entry point, and you can see here we add the agent and then add an input, whatever the input was. So if you're building like a chat agent, for instance, this would be the user query, and then that user query basically triggers the agent. The agent then does whatever it needs to do, performs a task, and then it will send a response. Since this is a very straightforward agent, it's not doing that much. Basically, it's just an LLM that you're calling with this particular task, that the LLM outputs something. I haven't done anything special with this agent, so we'll just basically output plain text, right? Plain text, and that's what we'll get. So basically, you could think of it as one simple LLM call. This is why it's a hello world example. Again, if you want to run that, we have that code. I'm adding the code, the script name here at the bottom, but you can find all the code examples right here. All right, so and then let's get into some more fun examples. So that's the hello world. For those of you that are very new to this, I think that'll be useful. But let's talk about like a simple agent that we can use. So something more interesting that we can do here. And I have it here. So what I'm going to do is I'm going to shift over to my coding environment. So here I have this. Let me just expand this one. So I have this single agent right here. And this single agent, basically, you can see the code here. This stays the same. I'm not doing anything special right here. It's very similar to the other example. And then this one basically creates an agent, right? So you're using that agent class. And then you can see I call it MathTutor. And then I just give it the instructions. Again, this is not doing anything special. And I'm actually not telling it or forcing it to output anything specifically in terms of the type and so forth, which you can do with this agent. I'm just telling it, hey, operate as a simple LLM. Here's the instruction. And here's the query. And then this will be the user query here. So what is the square root of 16? And then you can just run it, and then you can output it. So I'm just going to show you here. I am going to run this very quickly just to show you that it actually works. So as I also do this, notice that I haven't mentioned anything with traces here, but this is already logging things automatically. I haven't done anything special, and that's because I've set this default OpenAI key. If you're using another provider, you might run into issues with that because you probably still need to have an OpenAI key to trace things inside of OpenAI. No, if you're using another LLM provider, you might want to look into the options of tracing with other tracing providers. All of that stuff is in the documentation of the OpenAI Agents SDK documentation. Go and check that out there. It's out there for you to check out. So here's the response that we got. You can see very standard response. It's in text, nothing too special about it. And I'm going to go through the actual response. But anyway, so just showing you a very single agent, simple example here. All right, so this is user input, MathTutor agent, final output. Very simple, okay? So let's add more complexity to this. So let's build, a multi-agent workflow. Again, these are sort of the, these are the design patterns. These are the recommendations. Start very simple, something like this. And then you will build something maybe that includes multiple agents, and then you want to connect them together. So we're using the Agents SDK again to orchestrate all of this, right? And we can orchestrate. This is, I think, a really cool part of it as well. You can orchestrate this using an LLM. So essentially using a language model to do the orchestration automatically for you. So this is really neat for like open-ended tasks, like research agents, where, as I mentioned earlier, basically you don't have like a predefined path or code path that you would take, and you wanted the model to decide on its own what are the next steps that it needs to take, right? So it needs to have the ability to plan and needs to have the ability to reason and all of these different capabilities. Or you can just do it in code yourself. And I like that flexibility because a lot of like simple applications that we work in, like the common agent use cases that we see, we actually code them ourselves because we love the fact that we can make them more deterministic. And so you can choose to do it either in code or LLM. So I'm going to show you two examples where we use both of these. So one for each. All right. So if you want to know more here, you can click on this. This is, I think, will take you to the documentation, more on multi-agents. So let's start with a simple one. I'm going to call this a marketing content creator. And this one is just basically a sequential agentic workflow. Sequential means that there is an input, right? Like a user query. There's like something like a marketing strategist, then it produces an outline. Then there's a content creator agent, which takes this as an input and then creates a draft. And then the output of this, okay, this one goes as the input of this content editor agent. Then this one does perform something, and then there is a final content, and then finally there is an output, right? So we have these specialized agents that we have designed in this sequential agentic workflow. So how would this look like in code? So let's look at the code. And this one is under marketing sequential agent.py. So let's look at that. So again, the code is provided for you. You can check out that after the webinar. All right. So here I'm gonna use, obviously, I'm gonna use the I'm still gonna use the agent component in the library. I'm gonna use, let's see what else I'm using out of the box from it. That's pretty much what I'm using, just the agent, right? So literally, I could have implemented this basically using an LLM too. You can easily do that. And I love doing these experiments because, again, I want the flexibility, right? Any framework that I'm using, I want flexibility. I want to be able to define it in code or use an LLM to do that. If you have the capability, I want to be able to do that. And that's a flexibility I think as a developer you should be asking for. All right, so and something that that is very custom that I love to also do when implementing these applications, as I was saying, like you want to take advantage of features like structured outputs, right? And structured outputs basically simplifies things and makes your program more reliable, and you want to take advantage of that. And in fact, because these these frameworks are built with these capabilities, you want to leverage that. So how do I use the structured outputs with the standard agent class here? All right, so for this example, what I'm going to do is basically, again, I'm going to create the first agent, which generates an outline. The second agent expands the content, and the third agent finalizes the content. So in the first one, I define this class here. I'm using base model. Where does that come from? That comes from Pydantic. I won't have the time to go into what Pydantic is, but basically it's going to help you basically create these data structures that you can pass to the agent, basically telling it, hey, I would like for you to output something that's structured, and I want you to follow this scheme, and instead of outputting something plain, right? So a plain text. And that gives me more control as a developer and instruct the system better what exactly is it that I want and I expect. So for the first agent, that's the marketing strategist, basically this one will output an outline. So you can see I've defined the outline here. And then for the second agent down here, which expands the outline into detailed content, I've defined this one here, content draft output. So this one is what is expected. And then finally, the final content output, then we expect this one. Again, these are data structure schemes that I'm defining. You can see they're very, very basic, though not that complicated. And where do I use that? Well, let's see. For an example, let's look at this one here. For the first agent, basically I tell it the output type is this. And then I'm enforcing essentially the agent to output something that's structured that then now I can use as an input to the other agent that comes next. And that, again, improves reliability, makes things more deterministic also. But overall, it's good practice to use structured outputs, even if you're not using agents, even if you're just using standard LLMs. It just increases reliability and makes things easy to debug as well. All right, let's see. So this is a lot of code here. Basically, where it starts, I have like a product name here. I have some brand guidelines, right? Typically in marketing. And then we have like a target audience here, just additional details that we can use. And then we have this function here where we create the marketing campaign. So basically that function will be this one here. And this basically creates the entire workflow. And in this case, we're not using an LLM to orchestrate this. We are actually doing it manually. This is what I like, because I could have chosen to do this using an LLM, like, using the Agents SDK to do this easily. But I want to have that ability to control over the code workflow, the code path that I want, right? So because I want this sequential flow, basically I tell it, here are the pieces of information. This is going to be the first prompt, right, to generate initial outline, and then I'm going to run the first agent, which is the outline agent. I get the output right here. Then once I have the output, I also use this, right? So this marketing outline output, you can see it up here, this one here. So that's the expected output. So I get that outline. And then once I have that outline, then that becomes basically the input to the next step and so forth, right? It goes in that sequential form. This is why it's called a sequential, agentic workflow. And then finally, I have a result up here. So I will call the 3 different agents, right, with the different inputs. And then, yeah, I have completed that. So let me run this really quickly here just to show you. You will have time, right? It looks like I'm rushing the code, but that's fine because I want to go through many examples as possible. But you will have time to run the code. This is why I'm providing the code for you. So marketing, this actually takes a little bit more time, but I want to run it because I want to show you also what happens behind the scenes. I think this is where the tracing capabilities actually is really powerful because you get to run. There's a lot of complex, steps that happen behind the scenes. And you want, at least for something like this, you want to have a good view of what's happening, right? What is this transformation that's happening? What does the LLM, what does the agent receive as input, and what does it output, right? So you want to have a good view of that. And that's where the traces capability comes in. If you're using other tools, you probably have to implement that yourself here, and then that will take more effort. But notice that there's nothing about traces here, and that's done for you automatically. I'll show you right now the results regarding traces. Okay, so this is the result. I have something on the terminal here. So step 1, step 2, step 3, and then finally we have the final output, which is this entire thing here. Now, it doesn't look so great on the terminal, but now I can then shift to traces, and I'm going to show you that now right here. So I have traces. So again, you need an OpenAI account. You go to dashboards, and then you have the logs. So all the calls are actually logged here as well. So if you want that, that's you can see here, this is the one I just did. And it's using GPT-4o, just in case you had a question on what the model was, because I didn't specify a model, but you can specify one if you want. This is the one that's using by default. I think this is one of the latest GPT-4o versions. And then here is the traces. So this is the one that I'm interested in. And because, we run each agent individually, so we had 3 different agents that we use the runner class to run all of these individually. You can see here that the 3 are already separate right here. So this was a math tutor example, but this one, for instance, the marketing strategist right here, you can see that there was one call. So we had that information here, and you can look at, okay, these are the actual system instructions. You can see how it appears nicely here. And then, finally, this is going to be the entire thing that we pass as input to the model. And then the model will have this output here. So you can see the output is structured like this. So basically, this output is what we're going to use as the input to the next agent, which is going to be this one right here, content creator. Again, one LLM call that we're doing. So it offers you some transparency, some visibility into what is happening behind the scenes. You can see also how much tokens as well. You can see that we specified the JSON schema here. We enforced that, right, structure output, and we have the model here that we used. And yeah, all of it is here. All the information is here. You can see how it's gathering all that information. This is the outline part. And then, yeah, that's just the final, output from the model. And then finally, the last step here, again, one call, and you can see the details there. And okay, you have the same thing. And then finally, you get the output, right? So this is the final output that we saw. Let me see where that is. Okay, so so this will be the final output. Okay, this is the input. The final output would be somewhere here. So that's what we saw in the terminal. Okay. Alrighty. So that was a bit of traces. There's a lot to cover here, but unfortunately, I won't have time to go through all of that. So I'll have to go. I want to show you some more cool examples here as we go. So we have done a very basic flow. We have covered a multi-agent workflow, but the sequential one where we manually use code to define how that flow is going to look and how the model is going to work. So in a sense, it's deterministic because you are implementing, the control flow for this agent. But let's say we wanted to add a little bit more, wanted to make it a bit more autonomous. So we'll get to that example in a bit. But let's say we also wanted to maybe add a specific guardrail for this. So how would we add a guardrail for something like this, for a workflow like this? So it's the same workflow. I have different names here. By the way, I just use an LLM to generate these little graphics for me. So it chose different names, but it's basically the same workflow up here. In the code, you will see that. But let's look at that. The same sequential workflow with the little guardrail. So basically, it's like this. So we have an outline generated by the agent, right? And then we add this specific criteria checker here. And this checker is basically going to decide whether we have enough information or the outline is good enough. So you define that via prompt. It's basically evaluating whether that outline is good enough. And if it's good enough, then it passes, then it goes into the next 2 steps, right? Similarly to what we saw up here. If it's not, then it's going to fail. We define what's going to be the fail action here. So that's really important, again, as I mentioned, because this enables you to build more reliable LLM applications or agents in this case. And so you want to be able to implement that using the Agents SDK. So here's the example right here. Let me see right here where it is. So with this one, and I'll just show you in the code. I won't run this one. You can run it on your own. But I want to show you what is the difference and how I implemented this with using my own code. So I think it'll be this one right here. So it will be basically this that I'm sending. This is the data structure, and it has passes, which is bool, true or false. And then it has this feedback, some feedback that we're going to get from the system, maybe on why it's deciding that the outline doesn't meet a specific criteria. So that's basically what changed in the code. And the criteria is down here, right? So you do that. I think we do this a lot. Obviously, with LLM applications, we do this in the system prompt, but because we're building agents, we can get to separate these different types. That's the whole point of building the agents, building with agents. So we have all the criteria here. Must have at least 3 main sections, blah, 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 and all of these different steps. All right, so where does that go? Again, it's the same code, but we just have that one extra step. So basically where I implemented that is right here. So when we get the first step, okay, you can see here, we have this extra criteria agent that we have defined, and you will find the criteria agent right here. So it's just another agent. Basically, it's another agent that we just set up for doing this, right? And this is really powerful because with this, then you can basically define a model. Because typically with criteria, validation, verification, things like this, moderation, safety stuff, you want to use a more powerful model so you can specify something like an O1 or an O3 mini, something like that for something like this. So you can basically go and say model equal, and use any of those models that you have. So that's nice that you get that customization. Okay. Again, nothing really changed in the code. It's just that addition of that agent. And then, it has that flexibility because I can just program this myself. Now, why did I have to do that myself? Why couldn't I just use the built-in guardrail? Because there is a built-in guardrail that I can use, and it basically simplifies the code further. Using the Agent SDK, it has the capability to do something like this. So I'll share an example of that, but I just wanted to show you that you can also do it manually if you want, right? If what they're offering you is not enough, you can basically define it yourself. And I like that because as a developer, I'm always implementing very new and novel ideas, and I want to be able to have that flexibility. So I just wanted to show that with that example. All right, so let's go into the other example here. Yeah, this is the tracer stuff that I showed you. All right, and then so I think one of the more, I would say, more advanced ideas recently that we have been experimenting is this idea of Orchestrator-worker, agentic workflow. Huge terminology, but basically what it means is you have a supervisor and you have like some workers, and the supervisor delegates tasks to these specialized agents. So this is really powerful because in a lot of cases, right? You want to make the system more automatic, right? More in a more automated way, so that it runs the loops by itself rather than you having to define like what we did here, right? We did the steps and we manually coded this code flow. But what if we wanted to make it a little bit more automatic? So we have the ability to do that with the Agents SDK, and that's what I'm going to show you. So I'm going to show you how to do that, and also going to show you how to leverage the guardrail feature from the Agents SDK. So the guardrail that we implemented here manually is now we're going to use a built-in one for that here in this example. So again, the user inputs something, we do a guardrail check. We check in this scenario here whether the question is a question that we can handle. So we have two different tutor agents, so history and math. If it's not related to these two, then we say that's an error. So we run the check here, and then if it passes, then we are going to assign it to each one of these. But instead of having to define that in code yourself, right? Why not use why not use this orchestrator that's going to determine that for you? Okay, so that's where a little bit of the autonomous part of this workflow actually comes into play, right? So this triage agent will decide whether it's a history tutor that we need or whether it's a math tutor that we need, depending on the user input. So again, adding a little bit more of an automatic component to this. So you can see this can go many ways. You can make it more complex. You can make information go back and so forth. And you can get pretty creative with this, but this is just a basic example showing you the idea. So where is this in code? Let me see if I have time. Yeah, I have time for showing you because I also want to talk about tools. This is probably one of the most important topics. I want to give myself enough time for that. All right, so let me go here, and I think I have it right here. This is the tutor multi-agent. This one, it's much shorter. Look at it. there is more complexity to this example, but it's more shorter in code because I'm using the built-in features, right? I don't have to implement things myself. So basically, we have a guardrail agent right here. You can see it. It's an agent, right? We have the output type right here. So this is the output type. It checks if it's homework, right, or not. Then it gives me a reasoning as well. And so how do I handle this? Well, I'll actually use the guardrail function output from the Agents SDK. So now I have that. I'm not, instead of handle it, myself in code, I'll just use what's already built in, the built-in functionality here. So basically, that's it, right? It has an agent, it has an input data, and we pass that to the runner, and we get like a final output with this criteria checker here, this guardrail. And then basically it returns this object here. It has output info. It has the tripwire triggered. Basically, what it's doing is saying if the agent decided that when it checks, decided that this is asking about homework or not, right? It's gonna trigger if it's not about homework. Basically, it's gonna send a trigger. Then it's gonna return some kind of exception or something like that. And then you'll see it in the traces how it looks. But that's basically the idea with this, right? A little bit more automation in this step in a bit. So here we have the two agents right here. And then finally, after defining these two agents, we have our triage agent, which is going to basically orchestrate, right? So hand off the specific tasks to the specialized agents based on the type of questions that we're getting. So in this demonstration here, we have two that we're running. So you can see here, runner run. Triage agent, we don't need to call the individual agents anymore because this is going to orchestrate that for us. And then we just ask it the question, who was the first president of the United States? What is life? Those are two separate questions, right? Two different calls. So let me run that for you very quickly here, just to show you the idea. So this one would be tutor multi-agent, tutor right there. So I'm just going to run this. So one of them, if you look at it, one of them is asking about, so this is probably about history, but this is something different. So I don't think it belongs to any of those categories, either in history or math. So it probably should trigger, right? So it should trigger, this tripwire triggered. It will probably give me some error here. And exactly what I said here, you can see here, guardrail input, guardrail triggered the tripwire. So we'll see more about that in the traces, how it looks. But the first question was indeed answered. You can see up here. So it doesn't look so great on terminal, but you can always go back to the traces and look at it. So traces, let's go and look at that. And this is why this is so useful. I mean, I got used to this so fast, just going back to traces and just looking at everything. All right. So it has the two different calls you can see here. We run two runner, right? Two different calls. So you can see here, triage agent. We did the guardrail check, and then this one decided to send it to the history tutor agent. So let's look at that example. So you can see how it looks, right? The whole detail here, the whole trace. You can check the individual ones when you run the code yourself, but you can get a view on how many calls were made. 1, 2, 3. You see 3 different calls here. This is for the criteria stuff, and then this one is just the response from the history tutor. So you can see the handoff as well. You can get more details on when the handoff is. And this is nice because now it looks at the code and says, okay, it's this one specifically called the history tutor. Now, if you imagine if you had a lot of agents, you'll want a good view of that, and this gives you that really nicely. All right. And then this example here is the one that triggered the tripwire here. So this one, again, you can see it has this little message here. So guardrail tripwire triggered. You see it here. And then it has this error. So you know something is going on here. You need to debug further. Or if this is the thing that you wanted to happen, then you will handle it in some way in your application. So that's the idea. This works really nice. This is pretty useful because a lot of applications that you build will have these guardrails, will have these verification steps. All right. So we have roughly about 20 minutes more. I want to go through a few more examples, but I also want to take, because there was a lot of questions here, I want to take some time for questions. Please leave your questions there in the chat, and I'll get to the questions in a bit. All right. Let's go here. So far, right? Very simple single agent, sequential agent, Orchestrator-worker. I think if you are getting into the landscape of agents and you know how to build these really well, and you know how to apply them to your use cases, I think you're far. You're already very far. So that's why I really wanted to cover these examples to give you a good idea of that. And from there, you can get pretty creative how you want to run these things. But I think for agent stuff, one of the more important things, there are two, right? There's tools and memory management. Unfortunately, I won't be able to cover memory stuff here. But the tool one, I think, is really important. So for the Agent SDK, there are different tools that are supported. So there are the hosted tools. Hosted tools are like retrieval, web search, and computer use. I think computer use is exciting. Computer use is the stuff that we're seeing with like the operator, where a computer is basically controlled, takes actions, and so forth. That I think is really exciting. And this capability already exists here. So if anyone is really interested in this, I will encourage you to actually look at this and run some experiments with this. I think it will be an interesting way to learn more about this Agents SDK. Function calling as well. If you want to use a Python as function, this allows you some customization. You can customize your own tool. So I'll show you an example of that in a bit, how I can do this. And then you can also use agents as tools. I like this because so far I showed you how you can customize these things. And sometimes the outputs of these complex workflows can be the input to other agentic systems that you're building. That's very typical when you're building with agents. So what you can do is you can convert all of this stuff into a tool and then essentially leverage it as a tool within another agentic system. I think that's a very powerful capability, and it's a very powerful, I think, design pattern when building with agents. All right, so this is just the example right here. So I want to show you two examples. So what I want to demonstrate here is basically have some assistant agent that can call the web, right? And then the web retrieves some information and then pass it to the agent, and then the agent can make a final response. So it's going to leverage that external tool. And then I want to show another version here. You can see the code here where we can implement this ourselves. So just in case you were wondering, what OpenAI, I get this question a lot, what OpenAI implements in their web search tool, what are they using? And maybe you have your own APIs that you want to use. I typically find this to be the case. Like, I don't use the search tools that these providers provide me. I prefer to have more control over that because I think search tools are, in my experience, they're a bit hard to get right. They are like any retrieval system. And so I need more control over that. So what I'm going to show you is two examples where I implement my own, and I'm going to use the XI API. XI API is a web search API. It has a lot of really cool functionalities. So I'm going to show you an example of how to implement that here. Same workflow, is just using the built-in thing here, and I'm using something that I specify myself using Python function, this one right here. All right, let me show you the examples. Now, I'm not going to be able to run this because of timing, but I'm going to show you the actual code just in case you're interested in this. Okay, so let's see. Okay, so this is the agent. Look how simple this looks. This is, I think, the reason why you want to have a framework, because it has all this built-in stuff, and you can quickly build an MVP, right, with this stuff. Like, you're in your business, you're in your company, you want to test an idea, very quickly you can get something running. So all I did was just add these tools, web search tool here that I imported from here, and that's it. That's all I needed to do. Yeah, I think I can run this just to show you that it actually works. Okay, Python agent hosted tool. And then for this, I think it's really nice that we have traces as well. Because for this, it does this call to the web search tool. And then you need to know, okay, what was the actual thing that it searched, and what was the thing that this returned, right? What were the results that it returned? Because that's what you will be doing essentially for this tool. Like, you will need to check that. And sometimes, again, the standard things that they offer you are not really reliable when it comes to web search. So you want to be able to implement and have more control over that. Okay, so here it is. I asked for, I don't think coffee is a good idea in Belize. Belize is pretty hot right now. But anyway, so it has some suggestions here. That's really nice. You got a nice output here. Notice this is a markdown as well. If you want to change this, you probably have to give it instructions. But I noticed that it tends to prefer to output things in markdown. Because again, when you see it in the traces, you will see that it's nicely formatted as the output. All right, so that's basic example here. That's what I asked. So now what I'm going to show you is how do you implement something yourself, right? You want to implement a tool. That's very common. So let's show you the example here. Obviously, a little bit more effort, more code. I implemented this using XI API, so you will need an XI API for this. I think they probably have free credits that you can use, free tier account. I'm not too sure about that. But this is very cheap, by the way. Like, I use this for all of my experiments and stuff that I build with search tools. I use this tool. I cannot recommend it enough. It's very great. It's very great. But they're not paying me for this, by the way. I just love the tool. All right, so I have all of these classes that I've defined. Again, you'll see my code. This is what I love to do. I love to structure things, get an idea of what the systems are outputting, structure outputs all the way, I just love building like this. I found a lot of success in terms of improving the reliability of these things by doing, following this best practice of structured outputs. All right, so I won't go through the entire code here, but basically this one uses an Nexus search tool. And instead of using the web search tool from OpenAI, I define my own tool and I define it in a function. You can see the function here. You need to, this is just the decorated stuff. So this one comes from here. You can see right there. And then I can get to define this. And all of this information is now going to be used by the agent. And this is really important, right? What you pass here in the docstring, what you pass here in the arguments and everything, it's really important because that's how the model knows what is a query, where do I get my query, right? The query is basically the what we're going to use to fetch the web data. So that this is really important. If you go into the documentation, there's more information about best practices, how to do this, but this is something that you probably have to put more attention. So there's a way also to print out the tools, print out how this is being structured. Basically, it's going to be a function call. You'll have that entire JSON schema generated for you. And that's what the agent will use to make the right call and pass the right parameters. And all of that is handled for you by the library. Okay, so yeah, so this is how it works. Now, let me see what I asked. I was asking something really silly with this. Okay, what is the latest news on Tesla? Let's see if that actually works. Python custom search agent. Yeah, so I mean, this is how I prefer to work and learn how to use these tools. I love to be able to test. My first test is whether I can, build the workflows that I work with. First of all, if I can build them manually myself. So I typically have like a simple use case that I use. And then once that's possible and I have that flexibility and I can customize things, then I worry about traces. I worry about all of these things that I typically use in the development lifecycle. So that's why I showed you sort of the process of how I think about these things. Things are really important. All right, so all of this is just, this is just what the APIs is sending me back, just opening that for my own purposes. But then finally here it says, here are some of the latest developments regarding Tesla. And they say something about stock performance, price investment, something like that. And then company evaluation strategy, partly due to or whatever. And then it gives you the nice little links here that you can click on for seeing more information. So all of this stuff you can structure how you want it. But it works, and that's what I wanted to show. Okay, so let's go back here. So yeah, that's it. That's basically all the examples. I mean, as I said, if you know how to use it like this, the only thing I would say, the memory stuff I didn't do, and I didn't talk about context management. If you really want to get serious about this, there's a context management section in the documentation. That would be the next step. So if you want to take on, if you want to continue from the examples that I pointed out here, go and check that out. Then there's other features like, voice agents. There's features like, even more complex multi-agents. Streaming as well is another interesting one if you are building applications like that. But yeah, that's the kind of sort of the next step. I also, before I end here, I wanted to share, we also have like courses that we're building for this stuff as well. We enjoy doing like educational stuff and making this stuff accessible to people. And that's why we're going to be doing a lot of these webinars more often these days. But if you want to get ready, we want to make it as easy as possible, people to check out the courses and get access to the content. I would say my recommendation, if you really want to get serious about agents, it would be like checking out these two courses first. This is the Introduction to AI Agents, high-level introduction to agents, all the stuff that we discussed, how you actually implement them for different use cases, and then Prompt Engineer for developers. For those of you that are more into like the coding stuff, this will be the recommended courses. Again, prompt engineering is going to be a key component of building agents. So that's what I recommend. Then finally, this one here, Advanced AI Agents, is going to be built on top of this. So for this, it will be for coders. It will be for people that are seriously building things like what I showed you today. And we'll also have a chapter also on the Agents SDK, how to build more serious and complex workflows. That's going to complement this webinar. So that's the idea. So this is coming soon. It's going to be launched, I believe, the 31st of March, end of the month, basically, I think around Monday. We're going to launch the first chapters. This is going to be, I believe, in my opinion, this will probably be one of the, probably one of the more advanced courses on agents that exist today. But we're working really hard to get this one out as soon as possible. It's really of high demand. Okay, so, and then one thing I want to call out, it's not just courses. We have an entire community behind this. This is for serious developers, serious people that are building stuff, that have a use case, that need support, that want to connect with the community, that, want to discuss with experts as well. We have a lot of live events, workshops, We have all that stuff here. We really want to create like a community of people, of experts, of people building and sharing as well. So all of that stuff is included in the academy. So when you join,